Leviosa. Wingardium Leviosa. Oh, hi there. I'm Rachel Villegas Villamar from Lazaro Francisco Elementary School. I can't seem to get enough of Harry Potter. But then, did you know that what seems like magic is actually science? In this two-part mini-series, we will explain the science, concepts, and principles behind what looks like magic. On the surface, science and magic probably seem to have little in common. One is an art of deception, while the other is an established entity based on hypothesizing, testing, repeatability, and theory. But there is science phenomena that appears to be magic, as well as magic that is based on science. First that we will do is the Burning Money demo. The Burning Money demo is a neat magic trick that illustrates the process of combustion, the flammability of alcohol, and the special qualities of the material used to make the currency. Here is what we need to perform the Burning Money demonstration. Paper bill. You may use a higher denomination if you're brave. Tongs, matches, salt, a solution of 50% alcohol and 50% water. Have you got them yet? Then let's get some money burning. First, prepare the alcohol and water solution. You can mix 50 ml of alcohol with 50 ml of water. Then add a pinch of salt to the water and alcohol solution to help produce a visible flame. That should do. Soak the 20 peso bill in the alcohol water solution so that it is thoroughly wet. Use tongs to pick up the bill. Allow any excess liquid to drain. Now, the moment of truth. First, smooth the alcohol water solution from the damp bill just to be safe. Are you ready for our burning money trick? Then let's light the bill on fire. And allow it to burn until the flame goes out. See? So why didn't the money burn? Here's the concept behind this experiment. A combustion reaction occurs between alcohol and oxygen, producing heat and light energy, and carbon dioxide and water. Here is the chemical formula for this experiment. C2H5OH plus 4O2 greater than 2CO2 plus 3H2O plus energy. When the bill is soaked in an alcohol water solution, the alcohol has a high vapor pressure and is mainly on the outside of the material. You see, a bill is more like fabric than paper, which is nice if you've accidentally washed one. When the wheel is lit, the alcohol is what actually burns. The temperature at which the alcohol burns is not high enough to evaporate water, which has a high specific heat, so the wheel remains wet and isn't able to catch fire on its own. After the alcohol has burned, the flame goes out, leaving a slightly damp exit. Want some more science magic? Let's try one with water and some kitchen spice. Sprinkle pepper into a bowl of water. The pepper will spread out evenly across the surface of the water. Dip your finger into the bowl. Nothing happens except your finger gets wet and coated with pepper. Dip your finger in again and watch the pepper scatter away across the water. Magic? It's not. There's science at work here. The pepper and the water science trick is one of the easiest magic tricks you can perform. Here's how to do the trick and an explanation of how it works. Pour water into a plate or bowl. Shake some pepper onto the water. If you dip your finger into the pepper and water, nothing much happens. If you put a drop of dishwashing liquid on your finger, then dip it into the pepper and water, the pepper will rush to the outer edges of the dish. What happened here? Let science explain it for you. When you add detergent to the water, the surface tension of the water is lowered. Water normally bulges up a bit, like what you see when you look at the water drop. When the surface tension is lowered, the water wants to spread out. As the water flattens on the dish, the pepper that is floating on top of the water is carried out to the outer edge of the plate as if by magic. After these two experiments, I feel like wanting a drink. Why don't we pause for a while and have a water break? I'll see you in 5. Apple juice, anyone? Wouldn't it be nice if one can just put in a straw in an apple and take a sip? But then, straw is not hard enough to penetrate through an apple. Or is it? This science magic trick is actually more of a stunt than a magic trick, but the secret lies in a scientific principle with the air. In this science magic trick, you cause an ordinary straw to penetrate deeply into an apple by simply thrusting the straw. If you've got great aim and technique, you can actually cause an ordinary straw to completely pass through the apple. We will need an apple and an ordinary piece of straw for this activity. Bendy straws will not work, so let's snip it off. It's all in how you hold the straw. It's important that when you grip the straw, you hold it near the end and place your thumb on the end, sealing the straw. With your thumb on the straw's end, you seal the straw. Here's how it works. When you thrust the straw into the apple, air is trapped into the straw, which causes the straw to become surprisingly rigid. It's this rigidity of the straw caused by the trapped air which allows the straw to penetrate the apple. Rest the apple on the bench or table. It's a good idea to protect the table or the surface with some newspaper. Holding the straw as demonstrated in the last step, Quickly thrust the straw into the apple, keeping your hands away from the apple. Now remember, this can be very sharp, so you have to protect your hands as well. If you are having little success, try trimming the straw to a shorter length. Of course, if a straw fails to penetrate the apple, the straw will bend and have to be replaced. Here's how it looks like. There you have it. Remember, there is magic in science and there is science in magic. That's all for now, and I'll see you again next week. Ciao!